Alright, so this question is largest rectangle in histogram. So you're given a height array. You want to return the area of the largest rectangle in the histogram. Alright, two solutions. First solution is using stack. Second solution is divide and conquer, which is going to be out of date for this question, but it's definitely a good practice to learn. So for the stack solution, I'm going to push an index into the stack, right? So stack, height index into the stack. So my base is definitely -1. This is base 0, 1, 2, 3, 4, 5, right? So how do I know when do I need to update the area? So think about this. If you have increasing order, you are actually expanding your minimum area, right? Your minimum area is expanding. So if you have another one, then you will just keep expanding your minimum area, right? Alright, so you are updating your minimum area, updating your area when they are going, when the height is increasing, which is not good. You want to update your area when it's decreasing. So imagine this is height of 1, height of 3, height of 4, and this one is height of 100, and this is back to height of 5. So what is the maximum area? Maximum area in this histogram is 100, right? It's not. It's definitely not. So if you think about this, 3 is height, and base is 1, 2, 3, 4. This is 12. How about this? 4 is height. 4 is height. 4 times 3 is 12, and then this is 100. This is 5 times 2, 10. So you want to know 100 is the base. It's not 12. It's not 10, right? So how do I know? So I'm going to back to the stack, right? So when I see it increasing, I just keep adding. So 0, 1, 2, 3. So this is increasing in height order. So my I is current at this position, which is 4. But how do I get my height, the area previously? We're going to pop, right? We're going to pop our height out. So my height is definitely using this guy. So it's going to be height at stack the pop. So this will be pop 3, right? However, my I is still here. I need to set I minus 1, which is what, 3, and then 3 is the index. I need to find out the base is going to be the previous guy. So it's going to be 3 minus the base is going to be I minus 1, which is 3, and then minus the peak value for the stack. So it's going to be 2. So peak. So this is your what? This is a base. Base times height will be your area. So just doing this, and then you'll be able to know it. So we will update in the area when you see the decreasing height pattern. And also at the end, so once you finish, imagine that you keep increasing, keep have an increasing height order, and then you finish the traversal. And then you want to find out the maximum height. You want to do it at the end before you return, right? So you will just, since we have -1 at the end, so we'll just keep updating my, keep popping, and then keep, find out the the maximum area between this, this interval, right? Something like this, right? Alright, so it will be easier for me to write some code on. So I'm gonna have a stack integer, and I'm gonna put a stack over here. And then I'm going to just push the -1 into the stack, and then initialize the result. So -1 is definitely a value that I want to know when should I stop, and when is the the clean I mean the clean area. I mean should be not area, it should be the clean container. So for in I equal to 0, I less than height dot length, and then I plus plus. And then I will definitely need to push the current index into the stack so I know the height. So if the stack dot peak does not equal to the -1, which is you can pop, right? The main thing in this for loop is what? Updating the area. So you need to pop, right? So if the current height I is less than or equal to the height at stack.peak, this is not good because it's decreasing. Do I spell this correctly? Yes, I do. Alright, so now we want to find out what is the previous height. It's going to be what? Height. Previous height is stack.pop. What is the base? It's going to be I-1 minus stack.peak, right? So this is how you get the maximum area. So what happens if you still have the remaining value inside the stack? So you want to say, well, stack. Actually, this should be easy. Well, stack.peak does not equal to -1. You are not allowed to use in a stack that is empty. I mean, -1 is always here, right? So you're going to have the same idea, but we don't have I. We have what? Height.length -1 minus peak. So yeah, pretty much this is the solution. Where's my mouse? Okay. Alright, so this is the solution. So using the stack, what? All of n for the space, all of n for the time, and this is popping out respectively between, I mean, you only have all of n for the for loop, and you stack the part is depending on your height. And I don't believe this take all of n. Like this inner for loop doesn't take all of n. It should take constant. So this will be pretty much the time and space complexity. So all of n for the both, if I'm saying this correctly. Alright, so another solution is going to be divide and conquer. So I'm going to explain what's divide and conquer. So you want to, so this is your diagram. Alright, so we need to find out the minimum index, the height index, minimum height index between two intervals. One is starting, the other one is ending. So at this point, the minimum height index is 1, and the minimum height value is 1. Right? It's just pretty lucky. It's coincident. All right. The base is what? Right minus left plus 1. 0, 1, 2, 3, 4, 5. So your base should be starting from 1, right? So you shouldn't have base 0. So it's going to be 5. So right, base is equal to right minus left plus 1. Plus 1. Okay, so we get a base. We know the minimum height, right? Let me erase this. I don't need this. So we will get a current area between these two intervals, right? So at this point, we need to split. How do we split? We need to split based on the minimum height index. So we'll get a new area that we will target, right? So at this point, this will be 5, 6, 2, 3. The minimum height index is this guy, 4, right? Value is 2, base is 4, height is 2, so you will have 8, right? You will have 8. This is 6, and this will be a right side of area. How about this? The left side is what? This is 2, and the height is 1, so it's 2. 2, 6, 8. Okay, 8 is the largest one for now. Let's look at this one. So I will split based on the minimum height index right here. All right, so the right side height, minimum height is 2, the base is 2, right? So at this point, this is what? 2 times 2 is 4. Okay. This one. All right, minimum height is 5. Minimum height is 5. Base is 2. So it's gonna be this area. So base times height 10. 2 times 5, 10. So you get 10. So you will just keep splitting until each bar become individual, and then you'll return. But in this solution, it's definitely TLE. Because there are too many value you need to recursively call, which is not good, right? So I mean, you will see later why is TLE. Height 0, and then it's gonna be the length -1. So we need to have a in get area, in height, in start, in end. We want to know when is the time to break the for loop. I mean break the recursion, right? So it's gonna be if the start is greater than n, I'm gonna break, right? So I will say return 0. Alright, in min height index is equal to, and just say starting at the at the beginning. I'm going to traverse from starting all the way to the end. I want to get if the current height is less than equal to, should I say equal? No, I don't need to equal. Less than the base, I mean the minimum height index. I will just update the minimum height index equal to 1. Now I will say current area equal to what? The height, height minimum index multiply the base is n minus star plus 1. So I will have the left area and right area, right? So just based on the argument, so star is not changing, minimum height index we are using in the current area, so we don't want to keep using this. So I would say -1, right area it will be height, and then it will be minimum index plus 1, and then n. You want to find out the maximum area between these two, between these 3 values. So this will be pretty much a solution. So if I don't have any typo, yeah. So this will be the entire solution. So let's talk about the time and space first before we submit. So this will be all of what? All of n each time. So all of n pretty much is okay. So you have all of n for the first time, and you cut down over here, and this is what? All of n divided by 3, and this is all of n divided by 2, something like this. Because it's almost half, right? So what is the time complexity? It's going to be n to the cube, right? Just just in this example, right? And then you need to keep doing this until this is what? N over 6, and n over 6, n over 6, n over 6, n over 6, n over 6. So it's going to be n over 6 at the end. So, which is not good. And you get TLE. So this will be a time, because these stupid things. And the space is constant, right? So I was trying to memorize the value I traversed, but I couldn't. So yeah, you get TLE because you get this amount of value inside the height array, which is kind of dumb. So this is why stack is better. So you traverse only one time, and then you remember your current current height already, so you don't need to keep doing this. And then this is all of them, right, all the time. So if you have question, leave a comment. Yeah, I spent a lot of time talking about this and recording multiple times because I had a little bit trouble explaining the logic. Alright, so I will see you next time. Bye.